I think without much delay, we could start. So, very good evening, all, and welcome to the final day of Engage 2025 workshop. So, today we have the last day. So, Dr. Shailesh will talk about multi-agent system. So, without much delay, I request Shailesh me to introduce the speaker and proceed.
Yes, sir. So moving to the session, we can know about our speaker, Dr. Sailesh Shivan. He's a distinguished technology evangelist, educator, and researcher with a rich blend of academic depth and industry expertise. He currently serves as the principal AI architect at Lenac AI Private Limited, a UK-based company, while on academic leave from his role as assistant professor in the Department of Computer Science, Kuching University of Science and Technology, KUSAT. Dr. Shailesh holds a BTech in Computer Science and Engineering from Kerala University, an MTech in Computer Information Science from KUSAT, and an MSc in Maths from University of Madras. He earned his PhD from the Department of Computer Applications, KUSAT, for his pioneering research on AI techniques for analyzing classical dance. With over 9 years of experience in teaching and research and 5 years in the IT industry as a senior software engineer, Dr. Shailesh brings an exceptional blend of theoretical knowledge and practical insights. His expertise spans across diverse domains of artificial intelligence and data science, including deep learning, computer vision, machine learning, natural language processing, data mining, soft computing, quantum computing, and knowledge graph. A passionate researcher and academic leader, he currently guides 4 PhD scholars as a recognized research supervisor under the Faculty of Technology, KUSAT. His academic excellence is further demonstrated by his multiple qualifications in UGC NET, JRF, and GATE. Dr. Shailesh is the author of widely acclaimed book Algorithmic Thinking with Python, which has sold over 3,000 copies and is celebrated for its practical approach to algorithmic learning. He has published more than 50 research papers in reputed international journals, conferences, and edited volumes, and holds 2 granted patents in AI applications. As a as a passionate knowledge disseminator, he has been a resource person for more than 150 workshops, seminars, and invited talks, empowering faculty, students, and industry professionals. He is actively collaborating with industries and government organizations as a technology consultant, providing strategic direction in architecting and deploying cutting edge AI driven solutions. Dr. Shailesh Shivan is committed to shaping the future of AI and technology research, driven by a mission to contribute meaningfully to the evolving digital world. Let's move on to the session. Over to you, sir.
Thank you, Srilakshmi, for the introduction. And first of all, I would like to extend my gratitude to Madhu Madhavan sir for inviting me as a resource person for this very well organized and wonderful FTP, and to the department and the institution. So, my topic for today is on multi-agent systems, and I have gone through the contents of past 4 days. You were started from LLMs and the further things like fine tuning, prompt engineering kind of stuff. Then moved into LLM, the orchestration part and all. So you may be having a great idea of what is agents and how the agentic AI itself is emerged. So the first part of the talk may be a repetition. So we can have this in a discussion mode. Then we can switch into the actual aspect of multi-agent systems. Okay. So hope my screen is visible to you, right?
Yes, sir. Yes.
Yeah. Am I audible properly?
Yes. Yes. Correct.
So, so these are the things that I would like to discuss on the agent patterns, applications of AI, agentic AI, then multi-agent systems, multi-agent system architectures, then agentic AI implementation framework, land graph, very particular framework used widely to implement multi-agent systems, and agentic RAG. And after that, I will drag you to a demonstration of two different applications built using agentic systems and a multi-agent system. Okay. So we can start with agents. Okay. And as you know, like agentic AI refers to the artificial intelligence system that can act autonomously towards exhibiting behaviors similar to human-like agents, like planning, decision making, and learning from the environment. Okay. And a simple example that I can put is like an AI personal assistant that schedules meeting, book travels, and or complete tasks based on the user instruction without being micromanaged. Okay. So it is an autonomous system, a kind of artificial intelligence system which is having an autonomy in their performance, and it is always work towards a goal, and which is having the behavior of a human-like agent. Okay, and the processes involved in completing the task like planning, decision making, and learning from the environment. Okay. So you are actually listening to the same definition of agentic AI for the past 4 days, right? So can you just can you anyone come up with the idea of how generative AI is actually different from agentic AI? I'm not asking about the answers. I'm just asking about the perceptions you have, and I want to make it more interactive. Like I'm not seeing you all, right? So if anyone can come up with your idea regarding what is your perception regarding the difference between generative AI and agentic AI. Anyone, please?
Mainly it is autonomous, like agentic AI is autonomous.
Okay.
Yeah, that is the main difference, I think. Generative AI cannot take autonomous actions. Like it can only takes prompts maybe and or instructions like.
Okay. Thank you, Reshma. Anyone else like how can we connect between this generative AI and agentic AI? Anyone else? Is there any relationship between generative AI and agentic AI?
Yeah, well, genetic AI can generate responses. Those responses are passed on to another agent from one agent to the other, and then that way it can accomplish one task.
Okay. So we could say like generative AI somehow comes as a part of agentic AI, right?
Yes.
Yeah, we
Yes.
can say that generative agentic AI systems are on top of Gen AI models like
Yeah.
GPT as a brain or something like that. They use it.
Okay. Particularly, we can say like generative AI models are becoming a component of agentic AI, right?
Yes.
Yeah. Okay. Thank you. Thank you for your response.
It
So,
helps in reasoning, planning, and it is the brain of agentic AI actually.
yes, exactly. Yeah. So, is there any idea like apart from this LLMs, okay, we are all using LLMs from the category of generative AI as a part of agentic AI, right? Can we use any other kind of generative AI model for this?
We can use other models, like we can scan an image and we can pass on to another that can decide what type of object it is, and we can pass on to other agent which can take some action based on the image. So something like that kind of. Maybe we can show an apple and say that purchase this object, so it can place an order for that object.
Okay, fine. So, the key characteristics of agentic AI, this is also maybe you were very much familiar with. Okay. The first, I just want to give you a picture of the simple agentic AI architecture. Usually, before that, see, the agents we are talking about in this scenario, is that similar to the agents in the old agent computing systems? So after listening to all these talks, all these lectures, what is your perception? Like we have sometime back, we have something called agentic computing, right? As a part of traditional AI systems. Is that same agents we are mentioning here with in agentic AI?
I think you're referring to the reinforcement learning agents.
Ah,
Is it that?
in reinforcement learning, we can have a part. Apart from that, you maybe heard about the Jade Java agent framework like stuffs.
The
Multi
environment to build up the agents,
ah
Jade.
yeah.
Yes. Yeah.
So in that scenarios, we mention about some kind of agents, right? So
Hmm.
if that agents are very similar to this or not, the agents mentioning in agentic AI.
They are they are kind of like that, but they are not same. That's what
Yeah.
I feel.
Because yeah, that is the first distinction we have to make. That is in the previous agentic AI, or not agentic AI, agentic systems like uh, agent network kind of stuffs. We usually have a program that is what we are calling as an agent, and the rules, everything is actually explicitly described using the logic or some other traditional AI systems. Okay, so everything happening is based on some rule based, like if else conditions or something like logic. Okay, the position logic kind of stuffs are happening there, but here in agentic AI, okay, or AI driven agents. We can also say that AI driven agents, the core aspect is the autonomy in their thinking, planning, and acting. Okay, so we usually give a prompt as an input towards the agent, or the agent receives an input as a prompt. It is having a perception module. Okay, that perception can be enabled with an LLM, right? And again, the LLM can also act as a planner. Then it will execute based on the tools associated with the agent. Then it will have an environment to get the responses. Then it will also have some memory, a long-term or short-term memory. Then based on that memory and the response from the environment, it can again iterate on the planning and execution until the task is done. This is a very simple illustration of an agent. Okay, so what all kind of properties an agent in AI should possess? So the one kind of properties reflex, and the agents having the reflex property is actually called as a reflex agent. So it responds only to the current perception. Okay, it is stateless. It is not having any kind of memory or something like that. Say a thermostat that turns heating on or off purely based on a current temperature reading. Okay, so we can actually consider this property by relating with the old agent concepts. Okay, so you particularly you can realize this with the help of a rule-based system, right? And model-based agents are maintains an internal state that represents observed part of the world. That is, the world is nothing but the environment they are actually interacting with. Then the robot vacuum cleaner that builds a map of the environment and navigates, sorry, map of the environment and navigates even in the dark areas. Okay. And goal-based agents are actually select actions based on the desired goals. And then an example of a navigation system is an example of a goal-based agent, and utility-based agents are choosing actions from the minimize expected utility considering preferences and trade-off. The self-driven car choosing the route by balancing the time, safety, and comfort. And learning agent will improve performance over time based on the experience. So these are all actually related to the old agent concepts. But in agentic AI, we consider agents as a blend of goal-based, utility-based, and learning capabilities to create autonomy and adaptive systems. Okay, so the agents we are talking about that coming under agentic AI is actually a blend of goal-based, utility-based, and learning capable agents. Okay, so it can actually work towards a goal by using the utilities or the tools associated with it, and it can also learn from the environment to make it more capable. Okay, so these properties are very important. Like when we need to think about a single LLM powered autonomous agent. Okay, so this agent will possess a capability for planning, performing actions with the help of tools. Okay, with the help of tools. So the actions are performed with the help of tools, and it can also have a long term or a short term memory. Okay, and that memory will be used for planning, and the planning can be of anything like reflection, self-critic, chain of thoughts, and sub-goal decomposition, whatever it is. And also as a part of the planning, the reasoning can also be happening. Okay, so the tools are actually nothing but the facilities within an agent to communicate with the external world, that the more computing capability with the calculator, or more knowledge from the internet, or more like ability to execute a process with the code interpreters, those things can be enabled to an agent with the help of tool calling facilities, right? So an agent we are talking about, particularly an LLM powered agent we are talking about, is actually a blend of this memory, planning, action, and tools. Hope you got this, right? And so while getting a query, there is a, as I said, there is a perception module. That perception module will do planning or reasoning. Okay, or you can directly go to LLM for reasoning the code. Okay, sometime it may need not to go to the LLM for reasoning, but some LLM can also be used for the reasoning purpose. Then based on the plan, it will execute with the help of tools, and it will look into the responses from the environment and keep it in the memory. And if needed, it will again do the process of planning and execution iteratively. Okay, so this is a very particular working of an LLM based agent. Okay, and most of the time we we get confused. We might get confused with what is tool augmented AI and AI agents. Okay, AI agents. Can anyone tell me what is the difference, like tool augmented AI and AI agent? Any idea? Tool augmented AI and
So I mean, it's tool augmented is completely one task specific. Actually, the task is fixed, right? And agentic is kind of a, as you have mentioned already in the slide, it's a goal driven. According to the goal, it will plan the task, go through a different number of iterations, and plans the actions, right? And it's a repeated process actually, and it maintains the memory also as part of that. Whereas
oh,
in the tool based, there is no decision making as such. It's fixed.
okay, fine. So I can make it more uh, understandable. Like, see, the aspect of tool based and agent agent-based AI, okay, can be explained with, see, suppose if I'm asking, can you write a poem in English for me regarding the nature? So do we need an agent for this?
No.
No. Through what kind of AI we can do this?
To
Through what?
generative.
Through generative AI,
Gen AI.
particularly with a LLM, we can do this, right?
Yes,
And
any
if the
problem.
if the prompt is like this, can you write a poem regarding the nature based on current climate situations? Can an LLM will it be able to do this?
No,
Yes.
it
No,
will not.
it will
Standalone.
be tool augmented AI.
Yeah, that is the writing of the poem on the topic nature. Okay, writing a poem based on the nature is possible by an LLM, right? But the LLMs are not aware about what is the climate situation currently happening, right? So what should be done? The LLMs should get a capability to access the current climate conditions and understand what it is, and based on that, LLM can what? Write a poem or a story, right? So what capability we should give to LLMs then? We have to give an access to the external world by the LLM, right? There we are actually augmenting a tool to the LLM, right? A tool to the LLM, and that tool is actually used by that LLM whenever it is needed. Is it clear? Proper? So it is actually only reactive, and it stores it does not stores any kind of memory. It will just go and came up with the current situation, right? And no autonomy at all actually, or low autonomy is there. Learning does not happening there, and the only task, only goal is to perform a particular task. Okay. And in agentic AI, the situation is different. Like, see, suppose, see, this is not an agent, AI agent. Here, we have the LLM. Based on the user input, the LLM will decide on which tool to be called, and it will get the response from the tool. That response will be considered as a context, and with that context and the prompt, it will generate an output, right? Is it clear? Right. So, but when it comes to AI agent, okay, when it comes to AI agent, it's a simple AI agent. It will receive an input, okay, and it will call tools for getting the context, okay, it will call tools for getting the context. Apart from that, instead of generating output directly, it will generate some output, it will make a decision, and that decision will help to refine the output. If it is not appropriate, it will again go within a loop, and it will come up with a particular result which is very much apt for the given prompt, right? Then only it will give the output. So there is a power for planning and reasoning within the agents. Okay. Sometimes some people refer this as agent, but this is not particularly agent. This is only a tool augmented AI. Okay. And this is a simple agent. Okay. This is a simple AI agent. So that simple AI agent is particularly will be proactive. It will have a state, it will have a high autonomy, it will learn continuously, and it will work towards a goal, right? So this is the difference. Okay. Now, sometimes the other confusion happening is the workflows and agents. Are workflows equal to agent? Are workflows equal to agent? So, have you discussed about workflows in any of the previous lectures?
Yes, we
Yes,
discussed.
yes.
Yes. So, what is your understanding about a workflow?
It's a sequential execution of tasks, actually.
Sequential. Need,
Sometimes could be parallel.
yeah, it need not be a sequential.
Sequential, based on some rules, actually, right?
Based on some predefined path,
Predefined
right?
path, yes.
Predefined
Yeah,
code path.
yeah.
We can actually orchestrate what LLMs, right? So what it will do is it will take one LLM will take an input, okay, and it will generate an output, and that will be again given as an input to the next LLM. So that is a sequential one. Prompt chaining is there, right?
Yeah.
And sometime it may be parallel that we will pass the same prompt into two different LLMs and get the output. And maybe after getting that, we will synthesize the output to get a final outcome, right? Or maybe one can be act as an evaluator. Then based on that evaluation result, it can generate the output again for a particular input, right? And sometime it one LLM will be a router, like the input will be routed based on a particular prompt to some of the LLMs, right? So these arrangements of LLMs for achieving a particular goal is sometimes will get misinterpreted as what? Agents, right? But these are particularly what? Agent, these are actually LLM workflows. Okay. This is particularly LLM workflows. Okay. There is a website called Anthropic. Anthropic. You can actually refer that websites to get more insights on how this LLM workflows are actually defined. Okay. And what makes this particular workflows different from agents?
So the evaluator you mentioned here in this flow,
Yeah.
is it providing the feedback and again it is acting on that in the workflow?
Yes, but they are not connected to any external world or something. That part is missing.
External world in the sense external tools, you are
Tools
saying.
are not there.
Mhm.
So to make an LLM agent, there should be a part of action,
Mhm.
feedback, planning, response, and access to tools.
Yeah, but if we in this evaluator flow, if you add the
Yeah,
tool AI, right, we can add tools and functions there. Then
yeah,
would it become a
yeah. Then it become having some kind of autonomy, right?
oh, right?
Yeah. Then that how we are actually making it an agent. So, have you experienced the flow of Lang chain or Lang graph in any of the sessions, previous sessions?
Yes,
Yes, in Lang chain, you may be seeing that you can actually put a chain
correct.
by keeping the LLMs, by keeping other stuffs, right? That is
Right,
needed to get worked.
right.
And an agent is also building in the same way, okay? By keeping the required things for the feedback, for planning, for action and all. But we can also have some abstract models, abstract modules that autonomously work as an agent. If you create, have you heard about the React agent in LangChain? You can create an object of React class
Correct.
that itself will work as a agent. But apart from creating the objects like React, we with the help of chains and graphs in LangChain and LangGraph, we can also create an agent. Okay. So to create such kind of agents, we always rely upon this workflows, but along with workflows, we will give some other capabilities to make it as an agent. That is what I am putting here. Workflows can also be implemented as agent patterns. Okay.
Yes.
And the other confusion, the other major confusion is what is AI agents and agentic AI? What is agent AI agent and agentic AI? Is that a topic comes in any of the discussions?
Yeah, I mean, agents are like, individual agents with the individual goals. There is no, in between synchronization or orchestration, I think, right?
Okay.
Whereas multi-agent interaction is not there. It's in the agents as such. So if we apply the multi-agent patterns on top of this individual AI agents along with the orchestration, then it will become an agentic AI, agentic swarm or whatever.
So if I ask you a question like, can a single agent system be an agentic AI system?
And it it cannot be, but I mean that's how the terminologies are defined actually.
Yeah,
No, single agent will become under AI agent.
AI agent, exactly.
single AI can I make an agentic AI system with a single AI agent? That is the question.
If it is single,
No, I don't think, because it doesn't. Yeah, it may not.
Actually,
Yeah.
these definitions are not too strict.
Mm,
These definitions are very loose.
exactly.
Okay. So there is no strict rule like this is particularly AI agent, this is particularly agentic AI, nothing like that. Okay. How this is actually getting emerging is if there is a multi-step reasoning process need to be executed, okay, for planning and reasoning and completing a goal. Even if we have only one agent, we can call it as what? Agentic AI, right?
Oh, okay.
So the depth of the problem makes an agent system, it is whether it is a simple AI agent or an agentic AI, right? So we need not to crisply define AI agent and agentic AI particularly, but we can even build an agentic AI system with a single agent, but the depth of the task or the goal we need to achieve will be in a deeper manner. Okay. So,
so then, so sorry to interrupt.
yeah,
In multi-agent system, there are so many layers.
yeah,
So when you say in a single agent with the depth of reasoning, right,
yeah,
and planning, the many layers will not be used in that case.
yeah. There is no need to use many layers to become an agentic AI system. That is actually saying agentic AI deals with, okay, particularly deals with the agents, okay, the AI agents, its collaborations, its reasoning patterns, the decomposition, orchestration, and how to share the memory. All these things actually together form agentic AI system. Okay, so even if you have a single agent, okay, you can make it accessible to different kind of memories, right? You can actually give capabilities of different reasoning patterns, right, for a single agent itself. So the problems depth is actually getting more. I can tell you in a very simple manner. To build a RAG system, you may be familiar with a RAG system, right? Retrieval augmented generation.
Yes, I was about to come there. There is something
Yeah.
called agentic RAG. Again, that is a
Yeah,
different term.
That is what I'm telling. See, to build a RAG, you can use one agent. Okay, one agent for doing the retrieval process, for understanding the queries, for getting the context. Everything can be done with a single agent. Okay, so that is called as agentic RAG, right? But the same design, the same RAG can be implemented with multiple agents for performing multiple tasks within which is involved in the RAG application. Even we can build a RAG system without agents. Simple by using a workflow itself, using LangChain, we can build a RAG, right?
Yes. Without agent, with one agent, with multiple agents
With the
also we can
multiple
build.
agents
Yes.
We
also.
can build
Yes.
all these flavors. Yes.
Yeah, that is actually the flow comes.
Mm.
Okay, so the task is getting more complex and complex. See, usually we will use only one vector DB for a RAG, right?
Rack.
Right? See,
Yes.
think about we are having multiple vector DBs. Okay, and for optimizing the searching process on getting a particular context for a particular prompt, an agent is thinking, okay, and among which DB I should consider for getting the context,
Yes.
right? So that become an agentic RAG, right?
Yes. Correct.
So yeah, and in other reason for getting the context, I can also think about accessing an internet for a live information. There also you can put an agent, right?
So when sources are of different formats, we
Yeah,
call it as agentic RAG.
yeah, agentic RAG. So what is happening is, as the problem is getting more complex and the multi-level reasoning and planning is happening, then the system is gradually coming from a simple agent system to an agentic AI system. Are you getting it?
Yes. Yes.
Yes. Okay. And what are the patterns, agent patterns we can actually follow? This is actually when I go through the
Just
slide.
a quick question.
Yeah.
Yeah. Like, for example, based on the prompt itself, will it decide, it has to go to the level of agentic AI and which are the agents that should be chosen and orchestration, everything happens in the background, which is abstracted? Does it happen like that? Or
Can you make it more clear, sir? What is your query?
like, for example, based on my prompt itself, right?
Yeah.
Agentic AI will get invoked, right? Am I right? Or do we have to specify that, you
Actually,
use specific agents, then only it will invoke, or sometimes it might hallucinate and choose a very convenient agent or something like that? I mean, I want to understand the whole scenario, how it happens.
yeah, actually we can model that thing in
Okay.
different ways. Okay, I will be showing some kind of examples for you at the discussion part or the demonstration part. Okay, so the thing is, uh, you can actually accept a query. Okay, first the query will be interpreted by an LLM. Okay, so based on that query, it will actually decompose that query into different activities need to be done. Then by creating an agent, by initiating an agent, along with this LLM, we will be associating some kind of memory, as well as we will be associating some kind of tools, right? So the autonomy and the decision making power comes at that point. That is after decomposing the prompt into several tasks, okay, several tasks, it will identify which tool to be called. Okay, a one agent will be deciding which tool to be called. Okay, and which kind of memory I need to use, whether I need to use a memory for this particular stage. Okay, so it will actually decompose the entire activity into smaller activities, and it will execute, and it will gather the results, and after gathering, it will again reason it with, or maybe it is called as some kind of self-reflection. Okay, it will do some kind of reflections, and it will again go for validating the results obtained. Okay, and we can actually get the result. So the entire scenario now I have designed with a single agent itself, right? But the same situation, I can split it into different agents. So the design pattern we are using for building an agentic AI system is actually deciding which agent to be called, which agent to be invoked and all. Okay. So it will not actually go for hallucination and call some tools based on it. It won't do that. So we will always have strict constraints to what? To mitigate the hallucination kind of stuffs. Okay. So that will actually explain in this patterns. Okay. So a reflection pattern, or particularly a reflection pattern used in agentic AI system, works. See, AI reviews its works to spot mistakes and iterate until produces the final response, right? So it will get a query, the LLM will generate an output, okay? And after generating the output, the initial output will get reflected to a reasoning process. Okay, it is given to a reasoning process, and this reflection will happen for multiple times. That is what we are calling as a critic loop. Okay, critic loop. Then only after getting that reflected output, it will give it will give a response to the LLM, and it will generate the final response. Right. So the output generated by an agent will get reasoned, and it will undergo through a self-reflection process to obtain the refined output for a particular input. Okay, so the self-evaluation and iterative refinement is the key of reflection patterns. Okay, and it will be useful for hallucination reduction and answer polishing, and the implementation can be done by creating a chain of thought plus critic loops. The chain of thoughts is, see, this is kind of chain of thoughts. One LLM is generating output, and it will be given as an input to the LLM. Okay, and it will also iterate through that LLM itself for a critic loop. Okay,
So what is
so this
what is meant by critic loop? So there will be
critic, yeah, the critic loop is the output from one LLM. The reasoning LLM will be given as an input to the LLM itself.
yeah, okay.
We can actually model this with land chains and land graph.
Okay, or it will evaluate the output from the LLM based on various aspects. One could be maybe on the uh, on the relevance. Other could be on the correctness. So
Yes, in different aspect it will. That is actually a black box.
okay.
That will actually based on the query we are giving. Okay, we may be like giving a query as a part of it. We will say don't hallucinate. Okay, for generating answer. So it will verify the sources of the answers, and it will say whether it is hallucinated or not. Okay, you may be heard about the chain of thought process,
Yeah.
right? After giving the output, it will give the exact steps how it got how it is actually arriving at the answer. For more problems like mathematical solutions and reasoning problems, this is one particular way of prompt engineering. We can rely upon the results. Okay, so that process can be again internally used for agent reflections.
Okay, thanks.
Okay, yeah.
Sir, but
And
how can
yeah,
we decide that the reflected output is a desired output? Like maybe how that whether the reflected output is a desired output? Like
yeah,
it,
that is the thing. See, in chain of thoughts, the after getting the output, it will arrive at it will produce a sequence of steps to explain how the output is actually generated from the prompt, right?
Yes.
That will get re-evaluated with the reflect LLM.
Okay.
So if you are giving like what is the sum of 5 and 7? Okay,
Yeah.
5 and 7, and it is giving the output 10.
Okay.
Since it is giving the explanation of 10, how this 5 and 7 is added up to get 10, in some of the steps, you can actually find out some kind of mismatch, right? That mismatch will be tracked with this reflect LLM.
Okay.
Then it will try to create what? The reflected outcome.
Okay. Okay.
Then again, it will ask the LLM to regenerate or recalculate the process, and it will do this process until we are getting a proper reasoning.
Okay. I was under the impression that, when it gives an output, it thinks that it's the best output and it gives. And when
Okay.
we are not happy with that, it goes for the second best output and gives.
No,
Is that how
no,
it's not like that? Okay.
it is based on the reasoning process happening. That is what we are calling a self-reflection.
Okay.
The reasoning process based on it, it will again iterate through the LLMs for refining the output more correctly.
Okay.
Not we don't have a human in loop there.
Right. Okay.
Okay. Yeah. Then the tool use pattern, that is, the tools allows LLMs to gather more information. It is the same as that of how the LLM can actually access to the external tools. Okay. So first, if there will be a query, based on that query, the LLM will decide I need to call these kind of tools. So I will go for a vector DB, maybe to get a weather, I can call an weather API, and to search with Google, I can have a Google search API. Whatever I can do, I can access with the uh, contents of external world and take that as a context, and with that context, LLM will generate an output for the initial query, and that will be given as the response. Okay, so that is the tool use pattern kind of agents. And the React agent. Okay, the React agent is actually can be considered as a pattern, which is particularly giving the idea of reasoning, planning, reflection, and all. See how it is happening is, see, it will React combines the reflection and the tool use. Okay, so agent can reflect on generated outputs, and agents can call tools and observe results, and effective for multi-step and interactive tasks. And how it is happening is, see, there will be a query, and that query will be given into an agent. Okay, there is the agent, and agent is consists of an LLM. Okay, an LLM and a tool. So it will call the tools whenever needed. Okay, and it will get the results. Okay, and based on that results, what it will do, it will generate answers. Okay, it will generate answers.
So, what is the difference between the previous one? Here, where is the reflection happening? Because in the previous one, you have the critic one, right?
Here is the reflection, sir. Here you can see, right?
So, yeah, that is before tool execution or after tool execution?
Before tool execution.
But
Because
after tool execution also the reflection should happen, right?
this reflection can be happen, but in React pattern, this is the way we are executing.
Yeah, because after tool execution, if something is not right, again it has to loop in back and go to the first LLM and come back again. That loop should continue actually.
Yes, we can design in that way, but React agents are working like this.
Okay. So the reflection is at the first step only before the tool calling.
Yes, we can actually put a reflection over here too. And we can
Two
make it as
reflections. Yeah, there is nothing wrong. Yeah.
Yeah, that is our decision, that how we design the system.
Yeah,
This
and
is
the
a
response
generic.
the response can even directly come from the first LLM itself, because if the reflection happens also, right?
Yes, exactly.
Yeah, so it's that previous pattern can be merged here.
Yeah, this is a simple pattern they are actually giving. You can actually build a system like this. Maybe in programming, we have several design patterns, right? Singleton, factory model.
Correct.
That kind of a generic outline is actually giving for us
Okay.
to build the agentic system.
Yes.
Okay. And this is the planning one. Okay, planning pattern. Here, the query will be there. This is the entire, what you have asked is happening here. Okay. See, here, the query will be there. Okay. And the planner. Okay. The planner again will be an agent. Okay. That planner will will generate different tasks. Okay. And that task will be executed by a React agent. See here, in one step itself, the entire system of React pattern will come. Okay. And it will get the results and it will decide whether it is finished or not. It will give the response. So after the generation, again, there will be a reasoning process, whether it is good or not. That will be again can be channeled to the planner, generate task. And while doing the experiments, you can actually see this loop. Okay. So this is what we are calling as the planning agent. So these are all patterns. That is, we can actually combine more than one pattern to build an agentic AI architecture. Okay. So these are all single standalone patterns you can apply on your architecture. Is that clear, sir? Right, everyone?
Yes.
Yeah. So instead of solving a request in one go, the AI creates a roadmap, subdividing the task, outlining objectives and steps, iteratively execute and revisiting the plan. Strategic thinking helps solve complex tasks more effectively. Okay. So this is another planning pattern. And this is what we are calling as multi-agent pattern. Multi-agent pattern is nothing but multiple agent can collaborate each with dedicated roles, access to tools. And it is a role-based decomposition. That is, one agent can be a planner, another can be a worker, another can be a critic, another can be a router, and the parallelization, the dedication of subtasks, everything will be there, right? So that is how we are building a multi-agent pattern. And by following this multi-agent pattern, if you are building an agentic AI system, we can say that that is a multi-agent system. Okay, multi-agent system. Okay.
Here the orchestrator would come, right, in the multi-agent pattern, which can orchestrate among all these agents.
Yeah, we can actually use that too.
Yeah.
Yeah.
And
But for all tasks, there is no need of orchestrator. For some dedicated tasks, we can make use of an orchestrator. Otherwise, we can directly go with our own design. Okay. And some kind of load balancing kind of need to be done with multiple agents. You can actually go for this orchestrator. See, we are actually going to the next part of how the orchestration can be done.
Okay.
Okay.
And here each individual agent can be a React agent also.
It can be a React agent or it can be a planning agent, or it can be a React agent or a tool-based agent. Any kind of agent can be fit here.
Okay.
At every point. That is based on our need. That is why we call it as an agentic framework. For a particular task, we can decide our own workflows, our own agent flows, which kind of agents we can put. All these things are actually decided by us only. Okay. So the major thing here is the agent coordination via messages or shared memory is happening. That is the more important thing. Okay. We can actually decompose the task into role-based decomposition. It can be parallel or a delegation of subtasks, and we can actually coordinate different agents via messages or shared memory. So these are the different patterns I can use. So if you look into the different patterns, those things are actually apt for different use cases. See, if you think about reflection, uh, if you build an agent for debugging or strategy adjustment, what we can do? The reflection is only needed, right? Can you relate it with? Okay. Or if a tool use, suppose you want to do some kind of retrieval, a real world task like a ticket booking, something like that, or mathematical stuff, we can make use of what? Tool use. See, if it involves multi-step reasoning, code generation, kind of, suppose an architecture, a civil architecture need to be designed based on the constraints. Okay. And some kind of PCB designing need to be performed with the constraints we have and the connections we have. That kind of things can be done with the planning agents. And if the system is getting more complex and distributed one, then we should go for what? A multi-agent task. Can you just think about one complex uh, task as academicians we usually do? Any complex task, or a academician or a researcher?
Maybe creating a teaching plan and for a particular purpose, like whether different students might be getting into placement or higher studies or research, so tune it accordingly and give assessment based on that. Okay, all
Yeah,
those things are quite complex, right?
yes. And more relatively, writing a research paper,
Yeah,
that is also a very difficult, complex
yeah,
task, right?
yeah.
So suppose you can build an agentic AI system. If you simply give your idea and resources for literature review and all, if that agentic AI can prepare a paper for you, how good it will be. So such kind of systems can be created with what? Multi-agent systems, right? And the applications of agentic AI systems, I'm just going through this very fast. Okay, you can think about a customer service scenario, right? The personal productivity, the healthcare use cases, financial service use cases, sales and marketing, manufacturing and supply chain. Everywhere we can actually find out. Even in the software development industry itself, we can see what this agentic AI things are transforming the software development process now, because every company is instructing the developers to make use of this cursor or the GitHub Copilot kind of tools, right? Because it is very easy. Like even if I am into industry now, so 6 years back, I was in industry and I was a C++ developer, and to build a simple Excel merging application itself take 3 or 4 weeks. But now, with the help of this Copilot or a cursor kind of applications, I can even build a complete website for a RAG application with 1 or 2 hours. And this 1 or 2 hours is not only for simply creating my application. Instead, we can create, we can test, we can go through all the test cases, we can deploy. Everything can be done within the 1 or 2 hours. Okay. So these systems are actually transforming every every domains in our day-to-day life. Okay. And we can actually now particularly get into multi-agent systems. How the things are clear so far, right? Okay. Yeah. So what is a multi-agent system? As we see, a multi-agent system consists of multiple autonomous agents that can collaborate or coordinate to solve a task. Okay. And each agent has its own goal, its own reasoning logic, and its own tools of knowledge. That is the difference. Okay. So each agent is actually working for a particular goal, and it is having a reasoning capability and its own tools of knowledge. And the major thing is the agent communicate through messages and operates in a shared environment. Okay. So whenever you want to decompose a complex task, if you want to do parallel reasoning, if you want to do a fact checking and evaluation, and if you want to do a retrieval process from different sources, all these things, these multi-agent systems are apt. So this is how we can see a multi-agent systems architecture. See, here we have one agent. That agent is interacting with the user, okay, and that agent is associated with a particular memory and tool, okay, and this agent can communicate with other agent, and these agents will also have a memory and tool particularly, okay. So the coordinated effort of three agents with their own memory and tool towards multiple goals to achieve a final goal is actually happening in multi-agent architectures. Okay. So what is the difference between single agent systems and multi-agent systems? One autonomous agent interact with the environment. It can plan, call tools and respond. If another agent is invoked as a tool, see, that is a very important point. If another agent is invoked as a tool, that agent is treated as a part of the environment, not further modeling or coordination is happening. So even if we have two agents and one agent is actually calling the other agent as a tool only, there is no coordination or modeling happening there, then also it can be viewed as a single agent system. But for multi-agent system, see multiple autonomous agents that model each other's goal, memory and plan. Okay, and agents should communicate, cooperate and coordinate, and supports distributed problem solving and multi-agent reinforcement learning. Okay, so this can be a picturized view of single agent and multi-agent system. An agent you can call different tools, right? And if one tool can be an API like read or write documents like that. But here there are agents. Okay, this will be an agent. Okay, again this team will be an agent. These agents and this can actually have memory and tools. Okay, so this will be a supervisor like architecture like that. We are actually discussing it. Okay. So the architecture for multi-agent systems can be centralized or decentralized. So what do you mean by centralized? A centralized unit store global knowledge and orchestrate agents. Okay, so what is happening with this? It is easy to communicate and it is actually having a uniform knowledge over all the agents. But there is a single point of failure in the centralized network. But in a decentralized manner, the agents share information with their neighbors. Now global store will be there, and this thing will be more robust and modular, and hard coordination and global optimization is needed for this. Okay, and when we are organizing the agents in a particular structure, the usual the patterns we are actually using is one can be hierarchical. A tree like with varying authority levels can be centralized or distributed. Okay. Holonic. Holonic is nothing but agents grouped into holarchies. Okay. Holarchies is nothing but a holon act as a composite entity composed of sub-agents. That is, if, if you have one or more agents work together as a single agent, okay, works together as a single agent, that can be considered as a single holon, right? And such collection of holons again can be a particular multi-agent system. That is what we are calling as holonic agent. Okay, and temporary then collision collation is actually a temporary union to boost utility. That is, they will act independently, but whenever needed, it will come together and perform a particular task. Then it will get redistributed. Okay, like that. Coalition is actually the another kind of thing. And the team is actually a networked way of architecture, like persistent cooperative groups with interdependent roles will be there. Okay, that is what we are calling as Teams architecture for multi-agent system.
In the previous slide, sir, can we go to the
Yeah,
previous slide? In
yeah.
the decentralized network, like how the information is shared without a store actually? Is it like a temporary memory or it is
Yeah,
queued?
it can be used
Kafka
to
queues, yeah.
message passing.
Message passing, yeah. Kafka queues kind of
Yeah,
Kafka.
such kind of things can be done. See, suppose if you want to communicate with one holon in one uh, holarchy, okay, then we can actually use some kind of message passing systems, or you can simply use a link in LangChain. You can see we can create edges between two nodes, right?
Right.
that edges will carry some kind of information towards the another node,
Okay.
even without in memory.
Even without a memory. But
Yeah.
why the coordination is hard, it was mentioned, sir, like in the distributed one, but still it can be done, right?
Because the connection become very dynamic. Okay, the connection will be very dynamic because sometimes the connections will be there. Okay, because if it is centralized, one particular node will be assigning jobs to others, assigning memories to others, like that. So the coordination will be easy. But each one is doing independent tasks. It will be difficult to coordinate and all.
Yeah, but still systemically we can make smooth by
Yes,
using this
we
Kafka queues and all, right? Then the communication is seamless
yeah,
if you use that.
communication can be, but there will be multi-path executions too.
Mhm.
So sometime on a reasoning, we will be getting a proper result. We can go with one path.
Mhm.
In some situation, we have to go with another path. So then there won't be no any particular fixed path to move or the communicate between the nodes and all.
So
So that
in
will
that
be some.
in that case, what is the best practice to avoid that anomaly? You choose a hybrid one, use a persistent memory as well as the queue,
Yeah,
both.
that is actually we are going to discuss in the next slide. We
Okay,
have
sure,
some
sure.
different patterns. Okay.
Okay.
Yeah. And the nature, the agent behavior within the uh, multi-agent systems can be viewed in two different ways, the forking and the swarming. Okay, in the forking, it will actually having a separation to avoid collisions with nearby agent. It will work in a very independent way, like you can see how the hens are actually there in a poultry farm. They will randomly move somewhere, right? There is no communication at all, right? But in the swarming, it is actually self-organized or emergent self-organization with decentralized control is happening. How the swarm of honeybees, okay, or how the swarm of birds are actually operating together to achieve a particular goal. So the behavior of the agents within a multi-agent system can be viewed in two different ways. One is like forking and other is like in a swarming way. Okay. So the advantages of multi-agent systems are the flexibility, scalability, domain specialization, and high performance. Okay. And what are the real architectures we practice while creating the multi-agent system architecture? So the first one is the
Sir,
network.
sorry to
Yeah,
interrupt.
yeah,
Sir, advantages we understood. Now the to coming to the limitations, right?
yeah,
If one agent is unable to do for some task or unable to connect to some things, so how does it handle the situation?
yeah. We can actually write rules for it. We are actually going to how to deal with how to write prompt for this multi-agent systems. Okay, in that prompt design part, we can actually handle this kind of issues.
Okay.
Okay,
So, but the other agents will be functioning efficiently
yeah.
if it is not taking any input from that lost agent.
There won't be such kind of lost agent because these agents are actually having the capability of self-learning, right?
Okay.
It is actually getting evolved after each failure. So
Okay.
one time if it is getting failure through the self-reflection, it will automatically achieve the capability they needed to perform the task. Until that capability is achieving, we can actually see if you see the output of an agentic procedure, you can see that the node is actually repeatedly performing something until it achieve a better performance.
Okay.
So
So
it
one,
so it will get evolved automatically to solve the issues or to heal itself himself.
yeah. So there might be a delay in the response, or there might be a limited response. What I'm
Yes, yes,
getting.
that will be there because
Huh.
it won't be a very what time critic response like that. It will take much time.
Okay, so how do we know that we have to, this agent is is not performing up to the mark? So then we have to work on that agent to,
Yeah.
to
There
so
are tools, ma'am, in LangChain. Have you heard about LangSmith?
Lance Smith, I have not heard much.
Yeah, there is something called LangSmith.
Okay.
LangSmith is particularly used for what you have asked for.
Oh, okay.
Okay. There are tools to check the performance of a particular agent, to performance of the entire chain. If we are in an infinite loop or something like that, all these things can be tracked with the LangSmith.
Perfect, sir. Thank you. And one last question. What is the evaluation metrics for this type of architecture?
Yeah, we can actually look on it at
Yes.
the end. Yeah.
Yeah, thank you.
So the network kind of architecture, as you can relate with the network data models or something like that, agent can communicate directly with any other agent in the system. Each agent decide which agent to interact with next based on the local state and policy. See, when we are talking about this local state and policy, these things actually make some confusions. Okay, so while dealing with the lang chain, you can understand what is this state means. Okay, and see the key behavior is peer-to-peer communication, the dynamic routing, agent pick, interaction patterns at a runtime. These things are actually possible. The emergent cooperation where local decisions and messages, all these things are actually possible with this network architecture. And the practical use cases are ad hoc sensor networks, then collaborative chat agents, decentralized marketplace. For all these things, we can actually make use of network-based multi-agent systems. And the supervisor is the most widely used technique. A central supervisor agent will coordinates communication and allocate tasks among other agents. The supervisor decide which agent to call next for a given task. Okay, so that is how the supervisor architecture work for the multi-agent system. The centralized decision making for task routing, supervisor holds or has an access to global state that queues. And here, as the SAR said, the Kafka queue kind of stuff can be implemented, sir. And a sub-agent specialized for execution, supervisor orchestrate the entire flow. That is how the supervisor architecture work. And the practical use cases is customer care support pipeline, data processing pipeline, multi-step automation kind of stuff can be realized with supervisor. And supervisor tool calling is another way, like the supervisor treat individual agent as tools or APIs. Instead of delegating to a live agent, the supervisor invokes tool endpoints as needed. Okay, so it can be also viewed as a workflow. Okay, a supervisor workflow. There is another name for this supervisor workflow, tool calling workflow. Okay, and the rack systems, the enterprise automation. Here in the rack system, each of the node can be a retriever, a query matching model. Such kind of tools are actually used. Okay, see, we are actually going to see this. Okay, and enterprise automation, robotic control kind of stuff. And the hierarchical structure is like, see, multi-tiered systems. Okay, and a supervision is actually a kind of hierarchical model. So multi-tiered system that supervise, manage group of agents or other supervisor enables control of complex workflows and better scalabilities. Okay. And the last one is a custom flow. That is, you can make any kind of flow for your particular task. But we always recommend try to model your use cases in any of the previous workflow models. Then it will be easy to handle and think of it and debug it and uh, control it. Okay. So
Can you
the
go to the previous one, sir? The use cases of the previous one.
yeah,
Okay.
large scale enterprise orchestration, smart city management, complex ML pipelines. This thing can be done with hierarchical models.
Okay.
Okay. The custom workflows are like hybrid routing, the role-based visibility, rule engines, and regulator workflows, healthcare, trades, the hybrid manufacturing lines. All these things can be like, we can actually say different architectures can be combined in a very effective way with custom workflows. Okay. So decision gate for and trade-offs, how to choose a right pattern. So you can actually follow these things. Okay. So I will share this slides, because if we are discussing on this part, we'll be missing a lot of things. Okay. Is that fine?
Yes, sir.
Yeah.
Good.
Yeah. So challenges of multi-agent systems as agent malfunctions and shared failure models, then coordination complexity and negotiation overheads, unpredictable emergent behavior in decentralized systems, security governance and data quality concerns are also there. And so till this point, I have discussed about the theoretical aspects of multi-agent systems, and now we are actually going to see how these things are actually realized with the very famous tools like LangChain and LangFlow. Okay, so as we said, the popular frameworks we are actually using for implementing these kind of tools. I think you have uh, got an idea about Crew AI and semantic kernel yesterday, right?
Yes.
Yeah.
Yes.
So with, any particular implementation with land graph?
Actually, land graph we didn't do.
No.
And
So we will be actually discussing through the land graph today.
Okay.
Okay. So the languages are usually we can rely upon Python, JavaScript, TypeScript kind of stuff, and the core libraries LangChain, LangGraph, AutoGPT, Baby AGI, these things. Okay. Now we are actually using the LangChain agent architecture. Okay. In LangChain, an agent can receive an input. You can see this, right? Agent can receive an input. It can perform some actions. It can it can call tools based on the response. It can observe, right? And finally, if the process is complete, it can give the output. Okay. So can you just relate what kind of model it is?
single agent.
A single agent which follows that a kind of
Reflection. React pattern. Yeah.
React pattern. Okay. So this is a abstract agent in LangChain. Okay. And see, this is one very particular example. Okay. Can you see this function here?
Yes.
Calculate tool.
Yes.
That function is nothing but it will simply receive a string. Okay. An expression, maybe like 3 plus 5 into 2. Okay. And it will perform the evaluation. Okay. And it will return the result. Fine. And this is a very a replica of a search engine. Suppose you are giving a query, okay? That search engine will give a set of results based on the query. And to realize this, I am simply mocking this search engine. Whatever input you give, it will simply give a result like search result, product X released in 2010. Is that fine? Okay.
Yes, sir. Yeah.
So here I'm building two tools. T1 is a tool. Its name is search. Okay. And it is associated with the function search tool. Okay. And we are giving a description for the tool. With the description only, the LLM is capable of matching its requirement with this description, and and it will decide which tool is need to be called. Okay. So this description is very important. Here we are giving a description for the tool, search for product info, and return result. And the second tool is T2, and its name is calc. Okay, calc, and function is equal to calc under tool. This function is actually associated with it. and description is evaluate arithmetic expressions. Okay. Now I'm creating an LLM. Okay, an LLM, the Gemini LLM. Okay. Then I'm initiating an agent. See, this is an abstract object agent, and that is created using initialize agent function. There you have to specify the tools. Is that clear? You have to specify the tools. Then you have to specify the LLM. Okay. And you have to specify what type of agent it is. And verboses while doing the agentic process, whether the results need to be printed or not. Right? So we have created an agent which is having a capability of calling two tools. What all tools? A T1 is a search engine, search tool, and T2 is a calculator, right? Calculation function. And C, find the year product X released. Then compute year since released. Are you getting it? This is a complex task, right? I want to know in which year the product X is released and calculate since when it is actually released. Okay, how many years currently? How many years we have passed currently since it is released? Okay, so how it will plan? Can you just imagine? On decomposing these things, what it will
prompt you are giving?
this is a task we need to perform by the agent.
Prompt. Prompt.
Yeah, it can be a prompt too. So it will decompose these things into two tasks. How? I need to find the year the product X is released. For that, I can go for what? Search tool, right? And then to compute from the current year to the released year, how many years are there? To compute that, we can make use of what? A calculator, right? So on running, what it will do is, okay, on running, what it will do is, maybe I can show you the result. This is not a problem. Yeah, you can see this, right?
Yes.
Yeah. So the things are getting installed. Okay. Are you able to see this?
Sir.
Yeah. Yeah. See, on executing this part, you can see the output. Now the agent is started. This is a query. Find the year, product X, released, then compute since release. Year since release. Okay. Sorry. Yeah. Actually, there is a big version change is happening with LangChain and LangGraph. So many functions in the previous LangChain version was obsolete. So the previous codes done in LangChain won't work now. We have to find what all equivalent packages is available in the new version and replace it. See here, entering new executor chain. Okay. And what is happening? You can see the result while executing. This is the delay we have to expect while implementing this. Sorry, my Google Flash setting. Let me take my
It is giving 429 errors in some license.
yeah, it's actually Google API. While conducting one workshop, every participant use my keys. So my resource got exhausted.
But actually, it's gonna to give a result, right?
Hello?
We will get the result.
You will get the
Result.
result.
Yeah. In the query, you specify the keyword search and calculate. Is that is the reason to select a specific tool?
No, even if you don't give that,
Hmm.
you will get the result because it will automatically find out which one need to be
In that,
yeah, because from the nature of that is the capability of LLM. Find the find the year product X result. So the find may be related with the search. Search for the product info and return result, right? So this query will get mapped with this particular thing. Okay.
It will lead the research and discard.
Yeah, it will go for research. Then the compute is directly related to this. Okay. So in that way, I can maybe let me check with one of my other account. Okay. I don't know whether it is there. Yeah. So I hope you got the idea, right? How it is happening. Maybe I can share this. You can try with your own Google API key.
Yes, that's better, sir, actually.
Yeah,
Yeah.
we need not to spend much time,
Yeah.
right?
Yeah, we can proceed with others actually.
Yes. Yeah. So the idea is whatever we are actually trying here is see the find the year product X release. The entire instruction will get mapped into a separate task, and that task need to be completed with the tools, right? And the LLM will automatically find out through the description and the task to be completed. By matching that, it will automatically find which tool to be called, and the result from the one tool is actually passed to the next one. These things are actually done by the agent itself. Okay, hope you have the clear picture of this. And this is the another example. See here, what I have done is the same example, but instead of the mock tools, okay, instead of mock tools, I have used two tools. You can see I have used two tools, okay, SIRPAPI and LLM map. Okay, SIRPAPI and LLM map. SearchPappy is a tool. Uh, this is actually Search P API. Okay, for doing the Google search. Okay, and LLM Math is another mathematical LLM which will perform the mathematical computations. So the tools are SearchPappy and LLM Map, and we will initiate an agent with the tools LLM and zero shot React description. Then what is the weather in Paris and the square root of 123. Okay. So it will automatically find out the feather in Paris through SIRPAPI API, and also it will calculate the square root of 123. Okay. See, it could be better if I could. Can anyone give one API key if you have? Maybe I was exhausted with this. If someone can share one API key and then you can disable it, then I can try executing this. This will be a fun, like while seeing the result. If anyone is having, please let me know. Okay. So meantime, I will explain the other things. Then see, this is another example of how we are actually creating an agent-based system for building an agent that checks tomorrow's weather and decide play or postpone a match. Okay, play or postpone a match. So agent workflow will be like input, location and date. Okay, location and the date. Location to get my location, and date should be to check whether tomorrow is having a good weather or not. And node 1, we need a weather tool for forecasting, and node 2, we need are you giving some keys? Okay. Yeah. If it works, it is very good. Hope this will work. Yeah. Yeah, you also exceeded the quota. I don't know why this is happening.
Same error.
Same error. That is the quota. You exceeded your current quota. Please check the billing details. That is the thing. Or maybe we can actually I will share this code. You can actually try this by your own. Okay. Yeah. So we will be discussing about, yeah. So what we will do is, the one node is for weather tool for forecasting, LLM to reason and evaluate the condition, and the weather node 3 will be decision tool, return, play or postpone. Or optional, there will be a loops of self-correction. Okay. So why this example? This will demonstrate agent node use tools in LangChain. So show prompt designed for decision making and real world use cases to explain this. Okay. So the component are weather tool, API call, decision tool, rule reasoning, and LLM node to analyze it. Okay. So this is the input you have to. You are a match decider, an agent that decide whether to schedule an outdoor match at particular location. The input we are giving is forecast, the weather JSON, the constraint, threshold for rain, temperature, wind, player preferences. Okay. So how it will work? Task. The task you have to do. Decide, play or postpone. Give 2-3 bullet reasons. If postpone, suggest alternative slot. Okay. And a rule. The rain chance. See, these are the inputs we are actually giving to the agent. So rain chance greater than threshold, postpone. The temperature less than minimum temperature, postpone. Wind greater than a wind limit, postpone. Okay. So our output JSON will be like this. Okay. So the weather tool we have to create like a function. Okay. And the decision tool, again, we have to create like another function like we did before. And then what we can do, we can create a ChatGPT model or a Gemini model. We can use this tool, weather tool and scheduler decision, then create agent. In create agent, you can give the model and the tools. Then if you run the execution, should you play tomorrow, Bengaluru, minimum temperature, perception threshold and wind limit, it will finally give you a result on the decision by checking weathers and all. it will finally give whether we need to play or postpone. Okay. So the prompt we are giving in an agent is actually is of different way. Like we cannot give a direct prompt as we do in the LLM for this thing. Instead, see, agents can act autonomously. They need structured instructions. Prompt must define role, goal, tools, constraints. Clear action loop, improve reliability. So these things need to be kept in mind. Prompt must define roles, goals, tools, and constraints, and clear action loops improve reliability. Okay. So clearly define what the agent is and this level of expertise. You are an agent, a highly reliable role. Your purpose is to this. Okay. So example, you are a data curator, an expert in data cleaning. For purpose, your purpose is to clean and validate data set from ML workflows. Okay. And you can design the goals. Your goals are goal 1, goal 2, goal 3, etc. Success means these things. So identify error in the tabular data, repairing missing values, produce a validated result. Success means no missing values, transformations are logged. Okay. And you can then the tools the agent can use can be, you can use the following tool A, what it does, tool B, what this does. Okay. Use tools only when needed and return valid tool inputs. So the tools is like Python tool for running Python code, web search for searching information online. Okay. And the action loop can be designed in a way that follow this loop, think, analyze the state, plan, break the goals into steps, act, use a tool or output text, reflect, evaluate and improve, repeat until goal is achieved. Okay. So if the tool result is wrong, reflect and retry. Okay. And you can also provide the constraints, okay, and the output formats. Okay. So likewise, the prompt you are giving for managing an agent should be very particularly given. Okay. So the ready to use prompt is like, see, you are a research assistant, an academic research agent. Goals are summarize literature, identify research gap, propose methodology. Success, all info cited, output structure. You can use web search and Python tool. Action loop, think, plan, and act, reflect. Constraints, no hallucinated citations. Output format should be like this. This is the entire prompt we have to make while creating an agent. Okay. And best practice for agent prompt design is be explicit, no implicit. Everything should be explicitly defined. Use constraint to avoid drift. Use checklist and structured output. Add self-verification and define memory usage if needed. And the land graph is a very particular tool where we can use for creating multi-agent systems. Okay. And one of the major importance of land graph is that it is a stateful memory and it supports multi-agent collaboration. Okay. So the graph is actually a collection of nodes. Agent workflows as graph. So I will tell you how we can actually create. See, we have to keep in mind these things are the workflow. A state, a node, edges and graphs. State, node, edges and graph. States are shared memory during execution. Nodes are computation units. Edges are execution transitions. Graphs are connected nodes to define an agent flow. Okay. So I will be showing you, see here, we have something called a base model. Okay. A base model. So a base model is a pedantic abstraction of a graph. Okay. So here the state is a class which inherit base model and associated with each node. Okay. Associated with each node, it is having, if you consider this node, it is having two compartments. First one is input and the other one is output. Okay. Hope you got it. Okay. So Then we have an LLM. Okay, we have created one LLM. Okay.
Sir, actually, I have shared my Google API key. So can you try that?
Yeah, we can
Okay.
actually try after the
Okay.
explanation.
Okay.
Okay. Mm. Yeah. So after that, see what is happening is one LLM is there. Okay, one LLM is there. After that, what I'm doing is okay. See a node which is name is a respond. Okay, respond, and that respond is receiving a state. Okay, that respond is receiving a state. So within the node respond, you can keep an input and output. Okay, you can keep an input and output. And see that node is consists of an LLM, right? There is an LLM as a part of the node. Okay, and that LLM should be invoked with the input stored here. Okay, input stored here, and the output from the LLM. Okay, the output from the LLM should be the text returned by, sorry, the output from the LLM should be kept as the output. So whatever result you are getting from the LLM should be kept as this output. Okay, so associated with respond, you can actually have a state now. Okay, right? And how this is created? See, you have a graph. Okay, you have a graph. Within that graph, you are adding one respond node, right? And as I said, it is having an LLM. It can keep an input and it can keep an output. Okay. Now we set the entry point of that graph as what? Respond. Okay. And there is a graph, there is an edge, we are pointing to the end. Okay. Then we are compiling. Now what is happening? We are invoking the app, explain land graph in one line. Okay. Explain land graph in one line. This is what we are executing, right? So what it will do? The input, okay, the input will be stored. Input will be stored here, and while invoking the LLM, it will get passed to this LLM. Then the output from here is stored to output, right? And the return value from that node is stored in where? Result. So here we got the result state. Okay, and in that result state also it is passing the state as a result, right? So it is having the same input and output. So the output you got from this point will be here, right? So by taking the result of output, you will get the output. Okay, so this is how a land graph. So the entire thing is actually the graph. Here we have only one node associated with one LLM, and an input is mapped here, and an end point is here. Okay, now I can show you, see how a RAG system can be modeled with this. Sorry. A RAG system can be modeled with this particular land graph. Okay, see, for that, see, you can see one node, and every node is actually inheriting the state MSSAT. So that particular node is having a query docs, draft, final, and action. This is the state. Okay. So there is a planner node. You can see one planner node, right? Okay. That planner can store query, docs, draft, final, action, right? But it will keep only one value, that is there is a input called query. Okay, so we will be passing the query here. That query will be kept in the planner's query attribute. Okay, and based on that it will escape some kind of action. What action? It can be retrieve or recent retrieve or recent direct. Okay, so what is the criteria? If year is in the state query or released in the state query, it can be directly retrieved, otherwise recent direct. So this node will use only two values in the state, two attributes in the state, query and what? Action. Okay, and now see what will happen. A retriever agent will be here, there, right? And in the retriever, we are passing the state. Okay, that I will show you. So by passing the state from the query, okay, or from the planner, the retrieval will again get the query here, right? And that query will be used for getting the docs. So the query will be used to getting the docs using the similarity search in the DB. Okay, and there will be a reasoning agent. There should be a reasoning agent. That reasoning agent is actually the another node, will be another node. Okay, another node, and in the sorry, it will be another node. Okay, and that another node is also having a state, and it uses the docs. Okay, it uses the docs, and it will convert all the text, okay, into a particular prompt. Okay, docs will be used to create prompt. Okay, and it will invoke the prompt with LLM. Okay, it will invoke the prompt with LLM, and it will be kept in the variable draft. Okay, it will be kept in the variable draft. Okay, now the nodes are actually arranged. One more node is actually there, which is called as critic node. Okay, and what is the purpose of critic node? You can see that evaluate the answer. Okay, evaluate the answer state.draft. Evaluate the answer from the draft and provide corrections only. And if that critic node is again using what? The draft, right? The draft, and finally store the result in the variable final. Okay, now see the connections. The planner is there, retriever agent is there, reasoner agent is there, and critic agent is there, right? And how the connections are getting created? See, entry point is set to planner. This is planner, right? Entry point is, this is retriever. This is the reasoner. Okay, the entry point is set to planner, and there's a conditional edge. Okay, conditional edge between planner. Okay, conditional edge between planner and retriever. In which action? If the action decided here is retrieve. Okay, planner to retriever, there is a connection. Okay, retrieve. If the LLM is deciding here that we have to directly retrieve, then directly go to retriever. Okay. Otherwise, you have to go to what? A reasoner, right? Then the retriever and reasoner is connected. Okay. After retrieving, we are actually connecting to reasoner. The reasoner is connected to critic. Okay. The reasoner is connected to critic. Okay. And critic will give the end. So whenever there is a query, that query will be first evaluated whether directly answerable or not. If it is directly answerable, reason direct, it will be given to reasoner. Otherwise, it will go to what? A retriever. Then after retrieving, it will go to the reasoner. Then reasoner will make use of the docs from the retriever for retrieving the result, and it will get evaluated to the critic and directly giving back to the end node. So after compiling this, what we can do? We can give a query. Okay. We can give a query.
These are React agents only, right, sir?
Yeah, these agents are normal agents,
Not React agents.
not React agents. Okay. Now we can actually invoke the entire graph app by giving the query when was the product X released. So by passing through all these nodes, finally it will give the answer from draft and it is corrected as the final. Okay. So this is the workflow we are actually building with the land graph with multi-agents. Okay. So these are the conclusions, and I can show you one more.
There is a reasoning step also, right, sir? So why didn't we use the React agent there actually?
We can actually make use of that React agent.
Yeah, because in the previous scenario, what we discussed, right?
Yeah.
Single agent with React, correct?
Yeah.
That can come at the decision making point there, right here.
Yes, yes, you can include. I just want to make it simple.
Yeah, okay.
Yeah. Yes. And who is sharing this actually?
Yeah, myself, sir. Anjana.
Anjana. Anjana, I can maybe because of my account only this error is happening.
Okay.
As I'm using one account which is having an exhausted key. Maybe that's why it is actually happening. But no, entering in I will check. Otherwise, I will share this notebook with you. Okay.
Okay.
So
Okay,
you
sir.
can make a copy. And
Uh,
if yeah, this is again, yeah. I will do one thing.
mm,
I'll share this notebook with you. You can try it on your side. Okay.
Okay.
What is your mail ID?
Anjana,
ANJ
ANA,
NA
MELE,
MELE
DATH
DATH
at gmail.com.
at gmail.com. Is that correct?
Yes, yes.
So you just make a copy of this
Okay.
and try to execute with your account. Maybe
Ah,
this will work. Okay. So if it is working, please let me know. I will explain the next code in
okay.
the meantime. Okay.
Oh, okay, sir.
Yeah. So I just want to show you one agentic writer code 2. See, these are all package installations. Okay. See here, see, can you see this? The agent roles. I have 4 agents need to be created: a coordinator, a researcher, an analyst, and writer. Okay. And there we are actually mapping a prompt. See, what is the instruction to the coordinator? You are a coordinator agent. Your role is to break down complex tasks into subtasks, delegate tasks to appropriate specialist agents, synthesize results from different agents, ensure the final output is coherent and complete. Is that clear? Right? And for the researcher, you are a researcher agent. Your role is to gather information from multiple sources, verify facts and cross-reference information, identify key points, relevant details, and provide well-sourced information. Then an analyst, you are an analyst agent. Your role is to analyze, gather information, identify patterns and insights, compare and contrast different viewpoints, draw meaningful conclusions. And writer, you are a writer agent. Your role is to create a clear and engaging content. Okay. Structure information logically, maintain consistent style and tone, ensure accuracy while being accessible. Okay. Now, see, we are creating a multi-agent class. Okay, there we have the LLM tools and agents. Initialized tools are Wikipedia, Run, DuckDuckGo, search kind of stuff, and research tools are again this Wikipedia and all. Then the coordinator can use basic tool. Researcher can use research tool plus basic tool. Analyst can use Wikipedia and basic tools, and writer can use the basic tools. So initialize agent. So with this, what we are doing is we will initialize 4 agents. Okay, because it is iterating through agent role items, right? This is the agent role item. This is the agent of dictionary. So it will first go through this definition, this. So 4 agents will be created, and for each agent we have defined which tools need to be used, right? So with that, the tools, the LLM, the system message, everything will be passed along with while creating each agent, right? And after initializing the agent, we will process the task. Okay. So each agent will get executed, and the result from that task is again given to the result of the another task. Okay. So finally, explain the evolution of AI coding assistant, their current capabilities and further potential, including specific example. See, this is how it will run, entering a new execution chain. Then it will go through different stages and finally come up with a document which is explaining the evolution of AI coding assistants, their current capabilities and future potential. Okay, so maybe I can try this. Yeah, here also the resource is actually exhausted. Okay, Anjana, is that working at your end?
No, sir. For me also the same error.
Resource execution.
Yes. Yes.
Yeah, maybe I don't know how it is happening. You can actually try with your own code if you have not used so far. Otherwise, you can create a new Gmail account and get the key and use it. Okay. So the free
Actually,
plan,
sir, this is my new key. I just created that, but
that account.
yes.
Maybe otherwise, I can tell you the code is Agentic AI, right? Or it will be taking your code is in the chat, right?
Yes, sir. Yes.
I will do one more try. No. But it won't take much time like this. Usually, if it is clear, yeah, same method. I don't know. Yeah. So I will share the code. Try at your end. Okay, how it will work? It was actually working. Maybe some issues happening. So that's all what I wanted to discuss with you. Hope it makes sense to some extent. So if you have any queries, you can just ask or some feedbacks also.
Yes. So, thank you, Shailesh sir. Wonderful session. Definitely. It was very useful. Like you went through the basic things, connected through the right concepts, and it is a like a good concluding session because all the topics what we like, maybe some terminologies we discussed in the previous sessions. Now I think it is clear. Like land graph or that kind of terminologies may be discussed in previous session just as a word, but now we saw how it can be, yeah, rightly mentioned as an insightful session. Thank you very much.
Thank you.
So
Thank
if you have any queries, you can take up quick queries. This is the last session of our workshop. Or if you like to hear from participants how they feel this workshop, if you have any comments to share, any suggestions to improve, we invite you to share your feedback. Anyone, please?
Yes, so this entire series was very useful. So starting from the basics till the multi-agent system also we discussed, and we saw some practical flows also. So this gave us a real insight on how systems are working, starting from basics till end. So it was really very useful actually. Thank you. Thanks for organizing this session.
Thank you. Thank you.
Hi, thank you. Thank you for the sessions actually. And this is my third with IIIT Kottayam. Enhance, engage, finally to engage maybe. So it was
Thank you for
very well
this.
organized, sir. The team and the daily updates, everything. Like if we miss, like I was in between, I couldn't attend like 15 minutes. I was able to take it up through the recordings. So thank you for that prompt day by day recordings and yeah, very insightful, and especially Shailesh sir's session was also good and very insightful. Thank you. Thank you so much.
Thank you. Thank you.
Very engaging and very captivating session, Manu sir. It was really good. And Shailesh, thank you so much that today we could touch upon LangGraph practically. Actually, I was looking for it. And today was also very good on agentic RAG and these terms we had missed in the early days. But overall, it was well planned and well organized. Thank you so much. It was a much resourceful event for us. Thank you.
Thank you. So we have shared one feedback form, and also the quiz is up. You can take it up as sufficient time, and we will provide the certificates within next week. So there will be some delay, but we will provide within 1 week. Any other queries?
Yes, so this is Dr. Rizwan from IIIT University Jaipur.
Yeah, yes,
So
sir.
I hope I'm audible. So
Yes, yes, sir.
I must appreciate all the organizers from Indian Institute of Technology, Information Technology, Kottayam, for wonderfully organizing this complete workshop and FDP. And especially, sir, Dr. Shailesh, sir. So actually, I was going through various tutorials on Agentic AI and AI agents, but you know that we are teaching another load. So I was not able to complete any complete tutorial. So the thing is that today's session was very particularly crafted and structured that I was looking for. So thank you so much, sir, for explaining all those things in a very particular way, and from zero to, you can say, you have started with the agents, and a very basic discussion you have already started with that, and complete that agents and based complete programs and all those things you have shared, you have discussed. So one more thing, just I would like to request if we will be getting those collab files, links, and all those initiatives.
Yes, sir, I will be sharing everything, sir.
Thank you so much, sir. And I have gone through your profile also, sir, in between. So of course, we will try to be in touch. Thank you so
Yes,
much.
yes,
Sir.
yes,
Thank
sir.
you so much. Wonderful session, sir.
Yeah.
I
Thank
can
you.
share my profile, LinkedIn profile in the chat box. You can search for my profile too. Please get connected. I will be sharing more insights and resources on different AI stuffs. So be connected.
Sure, sir.
Thank you.
So one more request, like if you can turn on your camera, we can have a virtual photograph. Some of them left, but still. Could you please turn on the camera, others? So thank you. So I think now we can wind up this engaging sessions. We'll update the other materials, and some yesterday's material is pending. Will give us some emergency, so he will share it today, and we'll update everything by tomorrow. So once again, thank you for this engaging participant. I want to repeat that one because this was very engaging. The participants that make the speakers really encouraging. Like, that is a real gift. As Sir mentioned, especially Shailesh sir is coming, like he know the art of teaching as a teacher turned to industrial. So he have both touches that makes this final session more engaging. So thank you all for active participation, and thank you all resource persons. Thank you IIIT Kottayam administration and all our fellow faculty members, coordinators, especially Sri Lakshmi for volunteering this FDP. Thanks for the IT support. And once again, thank you all. Keep in touch. We'll update you. Thank you.
Thank
Have
you.
a nice time. Thank you.
Thank you, sir. Thank you. Thank you.